So question 14 is a slightly more challenging question. We are told that we have a fixed mass of ideal gas that undergoes changes in pressure and volume starting at L as shown. Now, we have this particular graph, and it's very clear to us that Lm is an isobaric process, okay, whereas Mn, we're not entirely sure. Alright, but remember, since this is a fixed mass of ideal gas, this means that U is going to be equal to 3 over 2 nRT or 3 over 2 P times V. So the important thing to note here is that the PV value, okay, P times V, gives me the internal energy, or is proportional to the internal energy. P times V is proportional to the internal energy. And of course, the internal energy is also proportional to T. So this means that P times V is proportional to the internal energy of the gas. Or the P times V is proportional to the temperature of the gas. Okay, so when we are dealing with this particular question, okay, let's just figure out what the PV value is for each respective point. So our first PV value is going to be 2 times 0.001. Okay, I'm just going to ignore the orders of magnitude, all right? So I'm going to take 0.002, all right, times 10 to the power of 6, okay? And at M, okay, if I ignore the orders of magnitude, I'm not going to bother writing the times 10 to the power of 6 over here, okay? 2 times 0.003 is going to give me 0.006. And finally, at this position, okay, the PV, P times V is going to be 0.8 times 0.005, okay? This gives me 0.004, okay? So essentially we can see that the temperature, okay, the temperature is rising to begin with. So immediately we have A and D, which are ruled out because the temperature must rise. Okay, on the other hand, in our next part, we can see that from 0.006 to 0.004, the temperature is falling. So the best answer for this is going to be B.